So it's my pleasure to introduce our speaker for this seminar series. So our speaker today is Dr. Einat Liebenthal. Dr. Liebenthal is a renowned cognitive neuroscientist with a profound understanding of the neurophysiology of speech and language in the human brain. As a research associate at the McLean Institute for Technology and Psychiatry and as an assistant professor of psychiatry at Harvard Medical School, she has made excellent contributions to our field. Dr. Liebenthal's academic journey began with a Bachelor of Science at Hebrew University, then a Master of Science in Neuroscience at Hebrew University, and then in continuing her pursuits, she achieved a Doctor of Science degree in Neuroscience from Technion Israel Institute for Technology. With a specialization in the neurophysiology of speech and language, Dr. Liebenthal is a leading expert in the field. Her research interests primarily revolve around exploring language deficits in psychiatric disorders and investigating language-targeted psychotherapeutic interventions. For her work, she strives to unravel the complex neural mechanisms underlying speech and language, offering insights into the treatment and understanding of mental health conditions. Utilizing advanced techniques such as functional magnetic resonance imaging and EEG, Dr. Liebenthal delves into the dynamics, interactions of language and emotion networks in the brain, and her research provides cognitive neuroscience framework for identifying and classifying mental disorders while paving the way for personalized and targeted psychotherapeutic treatments. Okay.
Thank you so much. It's really a pleasure. Thank you for the invitation and this opportunity to share my work with the CBR with everybody. Please feel free to stop me at any point since it's a more intimate group, and feel free.
Can I pause for a second?
I hope to convince you today that naturalistic approaches have the potential to uncover the neural mechanisms underlying behavior in real-world settings. I will also talk about how naturalistic approaches may be particularly potent for assessing language in individuals with language deficits. And of course, nothing is easy, so there are also challenges to using naturalistic approaches. So naturalistic approaches confer the challenges of measuring behaviors of interest in little controlled experimental conditions, and with no, one of the other issues is we currently have no standardized libraries of stimuli and paradigms.
Can you turn on your camera?
Okay. I don't know if I can do that without leaving without going, oh yeah, I can. Sorry, I can. Okay.
Yes.
Right. Okay. So first, so that we yeah, sorry, so it looks like the Zoom also cuts the top of the image, but I guess we'll have to do that. So first, so that we are all kind of on the same page, what are naturalistic paradigms? So naturalistic paradigms are ones that use stimuli that are rich, multimodal, and dynamic. So for example, in this clip of from the movie Moonlight, the scenery and the music and the dialogue work in concert to convey a certain narrative, a certain plot. Each element has its own time course, and the perception of the clip depends on the evolution of the time course of each of these elements. Another aspect that contributes to the richness of the stimuli is that there are unconstrained interactions between the actors or between the individuals and with their environment. And in naturalistic paradigms, none of these variables are controlled. So generally speaking, naturalistic paradigms aim to evoke more naturalistic patterns of neural responses, but they do not necessarily aim to mimic the natural world. So in the first part of the talk, I will focus on movies as stimuli for naturalistic study of verbal and nonverbal communication functions. And this work is done largely with Dr. Yan-Mei Tai at Brigham and Women's Hospital, and also with Jeff Gerard at the University of Kansas. And more recently, we're also trying to apply or to optimize using movies as stimuli for naturalistic study in aphasia, together with Swati Kiran and many Marty. So movie paradigms or movie fMRI became more popular in 2004 when Hassan and colleagues demonstrated that watching the same movie reliably elicits synchronized brain responses across viewers. And subsequent work showed that there are synchronized responses in distributed neural networks that mediate higher cognitive functions, including language, especially when the movie scenes are emotionally engaging and there's a structured plot. So we hypothesize in our work that compared to the unimodal static stimuli that are used in conventional language mapping tasks, movies are predicted to engage more completely the neural networks that support language in real life. More recently in later work, Hassan and colleagues stated that the brain has evolved to guide behavior in a multidimensional world with many interacting variables. So the assumption that artificially decoupling and manipulating these variables will lead to a satisfactory understanding of the brain may be untenable. So the bottom line is maybe the question that, at least from a theoretical standpoint, the question that we ought to be asking ourselves is, why do we not always use naturalistic paradigm when we study cognition? Naturalistic paradigms or naturalistic neuroimaging is also desirable for clinical applications. Compared to a paradigm with no explicit tasks, such as REST fMRI, movie watching limits mind wandering and constrains cognitive processes. Movie watching performance can be monitored via eye tracking. Compared to traditional task fMRI, movie fMRI is associated with reduced in-scanner motion, and it's commonly used in developmental studies to minimize motion and anxiety in children. So, as very eloquently stated by Eichhoff and colleagues, movies have the potential to be to the brain what running on a treadmill is to the heart during a cardiac stress test, meaning that naturalistic paradigms can be used to study brain function as it changes over time and across different contexts and levels of demand, and may reveal dysfunction that occurs in isolated circumstances. So in the studies that I will talk about, I will try to demonstrate this statement. So this is the final part of the introduction. As mentioned, there is nothing easy about naturalistic or naturalistic approaches. One challenge highlighted by Elizabeth Dupré and her colleagues is that currently databases of naturalistic stimuli that are used for neuroimaging are not open access. And the associated neuroimaging data that is being collected is typically also not open access. We have tackled another difficulty in a new database, Dynamos, which we will present on in the Effective Computing and Intelligent Interaction ACI conference upcoming. So there we've tackled another aspect that we think is very important, and that is that stimuli that are available in databases for naturalistic study don't have dynamic annotations, moment by moment annotations of the different features and the perception of the clips. And they also typically don't include individual subject level responses. And I will try to show why that is important. So in this, in our Dynamos database, we collect information using, we collect moment-to-moment annotations of the clips using software called Karma, developed by Jeff Gerard from the University of Kansas. And so the participants watch a movie clip here, a short 1-minute clip from Good Will Hunting. And at the same time, they use a sliding scale on the right here to indicate for each moment of the clip how it makes them feel, or their emotional reactivity. So in our case, it's a scale from -4 to +4. They indicate for each moment of the clip how the movie makes them feel. And so when we collect data from several participants, this is just an example of 3 participants here, not even participants in our study. You can see that you get a time course of the emotional reactivity for an individual. And so clearly the emotional reactivity, first it changes over time. But then interestingly, it's not exactly the same for each individual, right? So you can see that the yellow rater here identified some kind of negative event or event that made them feel negative. They identified that about 10 seconds into the clip, whereas the 2 other individuals didn't identify that as a negative event. But later on, the yellow rater was perfectly synchronized with the blue rater. So we collected these type of responses for 22 different clips. Those clips varied in negative and positive affect. This is when we asked the participants at the end to give us a holistic negative or positive affect response. So the clips holistically varied across a range of positive and negative affect. And the participants in the study also were diverse in their demographics. We put a lot of emphasis on that because we think that demographic variables such as sex, race, ethnicity, age can and probably do have an important effect on how people rate emotions and also more generally perceive clips. And so this is an example from one of the clips, more complete data from one of the clips, Aquila and the bee. When we asked so this is the distribution of the holistic ratings. So when we asked the participants at the end of the clip to tell us how positive the clip made them feel overall on several aspects, how enthusiastic, determined, inspired, and so on the clip made them feel, and also on several negative aspects, how nervous and scared and afraid the clip made them feel. You can see that overall, the clip made most people feel mostly positive or much more positive than negative. But then when we look at the moment by moment ratings, those are also fairly positive overall. So this is the mean of all individuals. It's about 90 individuals here. So overall, the clip also made the participants feel positive, but there was a sequence to this. So about 1 minute into the clip, there was an event that made most individuals, most participants feel positive. And then the positive response continued to build up and peaked toward the end of the clip. So there was an evolution in how people felt about the clip. And another aspect that is interesting here is that the distribution. So the black line is the mean across participants, and the different colors indicate the confidence intervals from 50 to 90 across for the distribution of ratings. So you can see that the spread of ratings across individuals is fairly stable. Not everybody scores the clips in the same way, but most participants show the same evolution of how they feel about the clip. So this is, this would be, if we wanted to study emotional reactivity, this would be a good clip because it elicits stable, reliable emotional responses across individuals. On the left here, we have additional metadata that we've started to collect about these clips. So here we asked the machine based on strictly the subtitles to tell us what the sentiment of the clip was for each subtitle. So here again, the scores go from -1 to +1, where minus is negative. The machine, or it's a software called Vader. Some of you might be familiar. So Vader sentiment analysis also tells us that that overall the ratings, the subtitles conveyed positive sentiment. But the machine or Vader is different from the human ratings in that it doesn't identify this kind of evolution that we see for the human ratings. It's just fairly positive overall. And that should be no surprise because there are many things that contribute to emotional reactivity, including the facial expressions and the vocal expressions of the actors, as well as other elements of the movie, such as the light and the music and so on. Any questions on this? So with this type of information, what we hope to do is, if we study the temporal course as well as the individual variability in emotional reactions and in the perception of naturalistic stimuli more generally, we can learn more about how the brain processes naturalistic stimuli. So talking about the brain, this is a different study, but same objective. We're interested in understanding how the brain processes naturalistic stimuli. So here we used a different clip. This is the Parent Trap, 7-minute clip from the movie The Parent Trap, which consists of some scenes with a dialogue. So you can see those here in the upper row, and some scenes with no dialogue, just music and general scenery. So we tested there were 22 subjects who watched that clip in the scanner, and this clip was successful in eliciting synchronized responses across individuals in distributed brain regions, including language regions in the temporal and frontal and parietal cortices, as well as additional regions. So this essentially replicates what others have shown before us, but it again indicates that this is a clip that successfully synchronizes between the brains of individuals who watch it. So in order to separate the responses to different elements of the clip, we used individual component analysis. So we extracted different components from the movie fMRI, and then in order to sort them and identify which brain regions they represent, we did spatial correlation with a functional canonical template, and we identified different components, including language component, an auditory component, visual, emotion components. So if we focus here specifically on the language component, so this language component, first you can see the anatomy of it. It comprises the temporal cortex pretty well as some of the left inferior frontal cortex. What is interesting is you can see here then we computed the temporal course for this language component across the mean and standard deviations across individuals. And the activity in this language component is greater during scenes with a dialogue. So here, and here, and here, and here. And there are troughs in the activity during scenes without a dialogue. So we get some anatomical, some spatial information, as well as some temporal information here about the activity in language areas during the processing of the clip. Then we looked at the relationships, the correlations between the different components. And so we see, perhaps unsurprisingly, that there was a strong correlation between the temporal courses of activation of the language and the auditory components. And that shouldn't be too surprising, since speech is an auditory signal. We also see a strong correlation between the temporal course of processing of the auditory and one of the emotional components. And that, again, shouldn't be too surprising, since I know that there are some music scenes, pretty emotionally engaging music scenes in this clip. So here is one more study in this part. Mm-hmm. I hope it's not me. Any questions, since we kind of stopped a bit? Okay. So this is the final study that I'll show in this part. So here, this is a different study, but using the same parent trap clip. Here we analyzed data from patients with a brain tumor, and the objective was to compare the quality of language mapping, which is very important. fMRI language mapping is used pre-surgically. So here we wanted to compare the quality of language mapping based on movie versus task versus resting state fMRI in brain tumor patients. The first notable finding is that in terms of head motion in the scanner, there was less head motion in the scanner during movie fMRI than there was during task fMRI. And that was true both for individual, there were fewer individuals where the data where they were not eligible for analysis because of excessive motion, and also in the individuals who were included in the analysis, the amount of motion was less. So this is, again, we don't know specifically why, but generally speaking, we think that, viewing a movie in the scanner as opposed to doing a task, especially for patients who are neurosurgical patients, is easier, puts less burden on the patients, and they are able to remain more, to move less, which is important for this type of, it's important for fMRI and for the success of the mapping. And then the other finding, which is extremely important here, is that in terms of sensitivity of the mapping, so movie fMRI versus task fMRI, we found that the sensitivity in temporal and parietal regions was better for movie fMRI than task fMRI. However, the sensitivity of the mapping was better in the inferior frontal cortex for the task fMRI. And specificity was actually better for movie fMRI. And when we compared movie fMRI with resting state fMRI, sensitivity was better for movie fMRI in the parietal cortex, and specificity was also better. So altogether, the bottom line is movie fMRI is pretty good for mapping language, especially in temporal and parietal regions. And we are thinking of creative ways to improve the sensitivity of movie fMRI in the inferior frontal cortex. This is actually some of the work that we're doing with Swati and Manny. So this is I'll pause a little bit here just to give a chance for questions, since then I'll be moving to a different kind of topic.
Einat, can I ask a question? Can you hear
Is
me?
anyone? Sorry, I don't know. I don't know the audience much, but is anyone here working on things that are similar, or? Is anyone using, are you neuroimaging? Are you doing neuroimaging?
So I work with estimates, and actually we have some movie watching data that we collected, basically we've been watching 68-second clips and they were asked to summarize it. And right now what I'm trying to do is do potentially a resting state estimates analysis with movie watching versions.
Yeah. So again, our findings, we have a tendency to think that movie fMRI works better than, or the movie neuroimaging, it doesn't really matter which type of neuroimaging you're doing, works better than resting states, for the reasons I mentioned.
What kind of tasks do they do in this time?
And that's the thing, they don't do any task. I mean, I'm sorry. You mean the task fMRI? Yes, sorry. This is actually a little bit of a weak point of that particular study, because here we only compared with antonym generation, which is one of the tasks that is traditionally used for language mapping. And the other task, with task fMRI, you always need to use more than one task, typically 2 or 3. So antonym generation is one, another is sentence completion, and another is, what is the third one? Sometimes story listening, but that's not often used. Sentence completion, antonym generation. I'm actually blanking on the third one right now. But those, they don't take a lot of time, but these are modular tasks. And I actually forgot to mention that one of the important reasons why we like to use movie fMRI in place of these tasks is that many of the brain tumor patients who are a candidate for neurosurgery have some type of language deficit. And so they are not able to perform those tasks very well, let alone in the scanner and when they're timed. And with movie fMRI, there is really it's a passive task, just watching the movie. So yeah, thank you for that question. That was an important point.
We have two questions from Swati.
Sure.
First one, what are the emotion ROIs you look at?
Mhm.
And then follow up, does the auditory ROI activation show up even when there is no dialogue in the movie segment?
So this is probably related to the prior slide. So the ROIs here were determined. There are different ways of doing this, but here the movie ROIs were based on a canonical functional template, Neurosynth. This is how, and the components were identified using spatial correlation with the canonical templates. And so the two ROIs, I believe that one of them, the ROI number one, emotion ROI number one is in the amygdala, and emotion ROI number two is more in the insula and the medial prefrontal cortex. And the second question was,
Does the auditory ROI activation show up even when there is no dialogue in the movie segment?
So there is a strong correlation between the language and the auditory ROI. There are temporal courses, it's 0.86. But what separates it is probably that we haven't looked at that in details. In this particular clip, I know that there are also segments with only music and no dialogue. So we would expect that the auditory ROI would be activated during the music segments, and whereas the speech ROI, the language ROI would not. But this is the reason why we want to test many stimuli, because this is the first stimulus that was used. This is the first movie stimulus that was used, and it got us so far, and now we want to use different. We want to test many stimuli and find stimuli that are optimal for activating speech and language areas, and others that might be optimal for activating auditory areas if people are interested in that. So that's the idea, to create a stimulus database with multiple different stimuli that are optimal for different applications. Okay, with that, let's move to the second part of the talk. So here I'll focus on computational analysis of verbal and nonverbal behaviors sampled in real-world settings. So this is probably no news for anyone that there is a lot of interest nowadays in digital phenotyping, or in other words, using digital measures to study behavior in real-world settings. So, studying human behavior when the human is performing in their own environment. So that's kind of the overall goal of this line of research. I'll present particularly one study, a longitudinal case series in psychotic disorder. So in this study, we are following individuals longitudinally in their own homes and their own environment. We're collecting or we're giving the participants the option to participate in multiple data streams. So they can come in for MRIs, which are collected not too often, every few months maybe. I should say the study was 1 year long, at least 1 year long, and some participants even participated for several years, up to 5 years. So MRI is one data stream. Another data stream is monthly clinical interviews when the participant comes in or since COVID, we've been doing these interviews via Zoom. So the participant comes in for clinical interviews where they are asked about their symptoms and how they have changed in the past months. And so these interviews are eventually used to score instruments such as the PANSS, the Positive and Negative Symptom Scale, that is often used to score symptoms in psychotic disorders. And then another type of data that is collected is via smartphone. So there are passive smartphone measures such as GPS and accelerometry. So we all know that our phones can collect these data for us if we allow it to. This is done via an app called, here it was BWI. There are different apps that do that. And then we also collect active measures via the smartphone. So these are called, these are surveys, ecological momentary assessments, where these are collected on a daily basis. So the participant can fill those surveys that ask them about how they've been feeling physically and mentally over the last 24 hours. And then finally, also via the smartphone, we can collect audio journals. So the participant is prompted once a day to record themselves with free speech. It's up to 4 minutes long, and it's completely open. And there are also one last type of data that are collected are wearables, so Fitbit from actigraphy watches, again looking at mobility. So the overall kind of an intermediate goal of this type of work is to detect features in the raw data that are quantitatively associated with latent psychiatric variables in different domains, including language, but also speech, executive functions, and affect. But a more long-term goal is to understand what kind of biological and environmental and social events trigger severe mental conditions such as psychosis and mania. So this is just to give you an idea of how much data are collected. It's a lot. We have close to 100 participants, and some of them have participated for several years, such that we are approaching a total of 100 years worth of data, not in all data streams. And you can also see that different data streams have different temporal resolutions, and not all participants participate in all data streams. So here is an example just of, I'm highlighting just the language data here. So here is an example from one participant, and this is coming from the clinical interviews. So just to remind you, this is when the participant comes in once a month for a clinical interview when they're asked about their symptoms. So this is about 25-year-old male. He's schizoaffective with bipolar type. He struggles with focus and organization, and he's consistently found to be mildly to moderately conceptually disorganized. So that means that his thinking is circumstantial, tangential, paralogical. He also struggles with abstract thinking and poor attention. So when we look at the excerpt, this is really just an example from it's a transcript of one of the interviews. You can get a sense that his vocabulary is quite good. He uses words such as complacency and counterproductive and mindset and opportunity gaps. And he uses those words correctly. But the most striking aspect of of the speech is actually how disfluent this person is. So they say he uses a lot of nonverbal fillers such as there is a little bit of repetition or stuttering. He uses also a lot of verbal fillers such as you know and I mean. There are mid-sentence redirects here that are noted by these marks. And when we quantify these features, so when we look at disfluencies per sentence, we see that the more disfluent, or I should say the more symptomatic this person is, the more conceptually disorganized they are, as marked by their clinical ratings, the more disfluent they are. And also the more symptomatic this person is, or the more conceptually disorganized they are, they're also more verbose. So they need more words to express themselves. So more disorganized, more disfluent, and more verbose. So this is an example from one participant, and actually the same participant. These are also a little bit from the other data stream. So this participant also is not a very good sleeper. If you can kind of get a sense here from their phone accelerometry, so the gray marks the time, but it's not the phone accelerometry, sorry, it's the phone screen on and off. So gray is when they're not using their screen, and red is when they are using their screen. So we don't know that gray means, we can't say for sure that they are sleeping during these extended periods when they're not using their phone, but when it's red, we can say that they're not sleeping. So this person tends to go to sleep very late, towards 4 a.m. and then they wake up quite late in the afternoon. And you can also see that the time that they go to sleep changes every day, and that sometimes there is red for kind of through the night. So they're a pretty poor sleeper. And here too, we can see that the more they use their phone during what is considered the average sleep period, the more symptomatic or the more disorganized they are. So when we do that kind of analysis across our entire sample, we find that several language features are correlated with conceptual disorganization. So across participants, the more restarts per sentence, the more repeats per sentence, the more verbal edits per sentence, the more disorganized they are, the more symptomatic they are. And similarly, also, the more verbose they are, the more words per second, words per sentence, the more total number of words, the more conceptually disorganized they are. And similarly, for the phone features, the more they use their phone during the sleep epoch, the more disorganized they are. So the reason all of this is interesting is that it's very difficult. If any of you is a little bit kind of familiar with psychiatry, it's very difficult to quantify how disorganized the person is, conceptually disorganized the person is. Sometimes people are, their speech is like a word salad, so that's very obvious. But most times it's not that obvious. It's not black and white. So quantifying how conceptually disorganized someone is not an easy task. Finding some measures such as disfluency and eventually maybe even sleep, and being able to quantify those accurately as an aid to considering whether someone is conceptually disorganized can be very helpful. Well, that's the goal of this line of work. And here one more example that we think is very promising. So the other type of data that we are collecting here is audio surveys. So these are submitted on a daily basis. They are 4-minute long. The participant gets prompted on their smartphone to submit an audio survey, and they can say whatever they like. And then again, on a daily basis, they are also prompted to submit surveys, those ecological momentary assessments, where there are 32 questions about their emotional, social, and physical functioning and their psychosis symptoms. As I mentioned, some of our participants are in the study for a very long time. This is an example of such a person. He's a 51-year-old male, bipolar 1. His mood is up and down. He struggles with anxiety. And he's been in the study, I think, he had been in the study for about 3 years, although here we only show data from 170 days. So one of our staff listened to those audio surveys across 171 days and noted all the events, the life events that this participant mentioned, such as their father's death anniversary, financial troubles, family reunion, or just how they felt that they were anxious. So that was from listening to each and every survey. And then we also fed those, the audio surveys into machine, the same Vader sentiment analysis that I mentioned before, and had the machine decide what the sentiment was for each audio survey. And then we looked at the relationship between the Vader sentiment. So first, when we had a human listen and find events that the human considered to be pretty sad or negative, then Vader also returned negative scores. And when there was a joyous event, such as the family reunion, the Vader returned a positive score. So Vader was doing quite well in analyzing the sentiment of the audio surveys. And then we looked at the relationship between the Vader sentiment scores and the self-reported EMA scores of the participants. So these are, we asked the participant how they were doing emotionally, socially, physically, and so on. And we have all these scores here. And so when we look at this, we found a strong relationship, a strong correlation between the self-reported EMA scores and the sentiment scores, the Vader sentiment scores of the free speech audio journals. So what this means is that we can get a good measurement. I mean, this is just one participant, but if this holds and we can generalize to multiple subjects, this would mean that instead of asking the participant to report how they are doing on several fronts, we could potentially analyze their audio surveys and extract much of the same information automatically from their free speech audio journals. So I think I'll stop there. There's another study, but I think I'll stop there for any questions, any feedback. I was talking to Manny before, and he was saying how he was interested in trying to use similar technologies with individuals who have language deficits, and certainly that would be a very interesting application. And we would not be the first ones to work on it. Aside from the audio journals are very interesting because aside from the language content, we don't have this analysis yet, but there is also the voice content, right? And so there is a lot of potential value in such samples that are more naturalistic because they are really free speech recorded at the participant's home. When some of the participants, such as this one, just got into the habit of recording themselves every day for 4 minutes, it served them similar to what a regular journal may serve, and there potentially is a lot of interesting information in, that could help therapists assist this participant if they needed, provide some objective and quantitative measures of how the participant is doing.
You're collecting all these multimodal data, and what are you trying to predict?
Yeah. So yeah. It's a lot of stuff, so I don't blame you. I only showed the potential value of the language samples, but I even did show you how this could be related to sleep. So how it's interesting to also record sleep, because sleep can affect clarity of thought, and clarity of thought in turn affects the speech produced by the participant. So we do think that there are relationships, but we are also collecting measures of actigraphy or of mobility, because that is another aspect of a person's well-being. The short-term objective is to detect features in the raw data that are quantitatively associated with latent psychiatric variables. So, for example, I was interested here in disorganization, conceptual disorganization. So the short-term objective, which I kind of demonstrated, is how can we quantify conceptual disorganization? Conceptual disorganization is very difficult to assess clinically. Can we find indirect proxies that would indicate to us the level of conceptual disorganization in the individual? Can we measure how disfluent they are, how their sleep is erratic, as a proxy of how disorganized they might be? But the ultimate goal is to see the relationship with that, and how these features may predict the occurrence of severe mental states, psychosis, mania, or severe depression. One aspect that I didn't emphasize enough is that these studies are conducted longitudinally, right? It's within person. So you're looking at how disfluent a participant is relative to themselves, and can that eventually predict their next burst of severe mental state. That is the ultimate goal is really to assist the therapist, to give the therapist actual data that they could potentially use when they clinically assess the patient.
We have another question from Swati.
Yeah.
What types of lexical coherence analyses can be used in a sentiment analysis, and what do they show?
Yeah, we kind of failed in this So coherence is certainly one of the type of language analysis that we're interested in, and it's more difficult to quantify coherence because the context is important. If you're in order to measure coherence, for instance, coherence in a conversation, it depends on how do you respond to the question. Do you respond coherently to the question? And so coherence really ought to be assessed in not sentence by sentence, but in context. And it is just a more difficult analysis, but certainly many other people in the field are doing it. We used Google VEC, I think, is the software that we used here, and it didn't show any significant relationship with the symptoms of the patients. And it may be I pointed to one of the problems with, at least with our analysis. Other problems were that in our particular sample, most of the participants were not very incoherent. They were in this kind of mid-range. They were not severely incoherent. And there may have been other limitations that I'm not thinking about, but that is certainly a goal in the field. And I think that one of the exciting aspects of this particular study is that we were able to show that something much simpler and easier to measure, such as disfluency, which we can measure accurately, is correlated with how conceptually disorganized the person is in terms of their clinical symptoms. We kind of bypass the issue of the difficulty of measuring incoherence.
4 minutes of connected space, they can do it whenever they want during the day. Right?
Yeah,
and
yeah.
Have time stamps for...
So these are great questions. So we put a lot of time to work with each participant and individualize, to ask the participant, when is your preferred time? Is it, before dinner, after dinner, early in the morning? I mean, every participant is different. Some participants are college students and they share a room with someone else, so they actually need to get out of the room, and other people are, I don't know, working or parents or what have you. So we also use other incentives to incentivize the participants to, participate as much as possible. So, we give bonuses for completing so many surveys a month, and more across streams. We give bonuses for increased participation, and but this is important because the audio surveys are relatively low burden, and some participants like them, and they use them as a journal. So this is potentially a digital measure that can have it can be extremely informative and relatively low burden for the participants. It's less annoying than those ecological momentary assessments, those surveys where, every day you're asked to respond. You can do it very quickly, but to the same 32 questions, how irritable have you felt over the last 24 hours? How sad, how was your sleep, and what have you? Yeah. Any other questions? All right. Thank you so much. Thank you for your attention. And any comments, any other thoughts that you have later on, I'd be happy to communicate and talk to you. All right. Thank you.
Thanks.